Hi and welcome. In this video, I will discuss some concepts related to VLAN operations, including access mode, untagged ports, trunk mode, tagged ports, native VLANs, private VLANs, routed VLAN interfaces, and VLAN hopping attacks. So let's start. Now in the first case, this is a switch which operates at layer 2 of OSI model, that is the data link layer. Now this switch has multiple physical ports attached to it, and by default these all ports are in single local area network. That is, all these ports are in single broadcast domain. So there are multiple endpoints connected to each of these physical ports. For example, the PCs, the printers, and the IP phones. Now, since all these ports are in single local area network, so the traffic which is flowing between PC and first port can be seen by all other endpoints. Now, for performance and for security purposes, we do not want to do this. Therefore, in the second scenario, what we can do is we can physically purchase 3 switches, and with first switch we can attach the PCs, and all the ports on the first switch will be in a single local area network. But since only the PCs are attached to this first switch, therefore we do not have any issue. And in the second switch, we can attach the printers and all the ports in a single local area network, but this local area network will be separate from the first switch. And with the third, we can attach the IP phones. And if the traffic from any single switch wants to communicate with the other switch or to outside world, then it will go to the firewall or to a router, which is a layer 3 device, and then it will flow to another switch or maybe to outside world. Now we have achieved our goal of security and performance, but there's a physical cost associated with this solution, and also the operations and maintenance overheads are increasing due to this solution. Therefore, we do not want to use this scenario 2. And what is the solution? So solution is the VLANs. So we will purchase a single switch which will have the VLANs feature, and nowadays all the switches support VLANs. So we can think of the VLANs or virtual local area network as 3 switches, but these switches are virtual and therefore their LANs are also virtual. So this VLAN operates at layer 2 of OSI model, that is data link layer. So with this VLAN feature, we can achieve the same level of security by segmenting the network into different virtual local area networks, and we will also increase the performance by restricting the broadcast traffic between same sets of devices. For example, the broadcast traffic between PCs will be restricted only to PCs, and the broadcast traffic between printers will be only be restricted to printers. And we can also arrange the devices in different VLANs as per our management requirement. And therefore there is and also there is no physical topology associated with this VLANs, and there is no physical cost associated with this VLANs, and everything is done logically on a single switch. So we will put two ports in VLAN 4. That is, we will do it by assigning by declaring a VLAN 4, and then we will associate each of these two ports with VLAN 4, and then we will also create another different VLAN, that is VLAN with ID 5, and we will attach two ports with this VLAN, and similarly we will attach two ports with VLAN 6, that is for IP phones. So with the first VLAN 4 we will attach two PCs, and with second we will attach two printers, and with the third we will attach two IP phones. And you can think of these three VLANs as three separate physical switches, which I have discussed in scenario 2. But everything is done logically over here. So all these ports are in access modes because each of these ports belongs to only a single VLAN at a time. So therefore these ports are untagged. It means that the switch, since know that a particular port only belongs to a particular single VLAN, therefore it will not attach a tag or a VLAN ID with the frame coming or going to this access port, since it know that this port belongs to VLAN 4, so there is no reason to attach the VLAN ID with the frame, that is the tag of a VLAN. Now one thing is that by default all these ports, once we receive a switch or we start configuring a switch, then all these ports belongs to default VLAN, that is VLAN with ID 1 or VLAN 1. Therefore we have to configure different VLAN IDs, and then we have to associate different ports with different VLANs, which I have done over here. That is, I have created three VLANs with VLAN ID 4, VLAN ID 5 and VLAN ID 6, and with each VLAN I have attached the ports belongs to different sets of devices, that is PCs, printers and IP phones. Now one more concept is the trunk mode or the tagged ports. So once we use the term access mode of a port or untagged port, so these two terms are synonymous. Similarly, the tagged ports or the trunk mode of a port is synonymous. Now the tagged is the inverse of the access ports, since in access ports we only expect the traffic from a single VLAN, but in the trunk mode ports we expect the traffic from multiple VLANs. So any port can be defined or can be configured as trunk port or as access port. So once it is configured as access port, then we associate it with only a single specific VLAN, and then there is no tag associated with the frame coming out or going to this port. And once we will configure our port as trunk port, then every frame going to this trunk port will have a tagged associated with this frame, since there are multiple VLANs configured on a single trunk port. So if there is no tag attached to a frame, then the tag port or the switch to which this tag port belongs will not be able to make out that to which VLAN this frame is associated with. So therefore we attach a tag with on the tagged port of the switch. So we'll declare a port as tag port. Then all the traffic which the switch will send out from this tag port will have a tag associated with the VLAN ID of that frame. For example, this is a second switch, and we have defined the same VLAN, that is VLAN 4 for PC and VLAN 5 for printers, and we have associated two ports with for PCs and one port for printer. Now we want to communicate these all VLAN traffic to the first switch. So therefore we will create or we will configure a port as trunk port. It means that it can carry the traffic of all the VLANs of this switch, and on the other side we will also create the same trunk port, and on both of these trunk ports we will define that these VLAN IDs are associated with this trunk port. It means that this trunk port can carry the traffic of these VLAN 4 and VLAN 5. Now once the traffic from second switch will go out from this tag port, then this tag port will attach the VLAN of that traffic with the frame. That is, if this frame is coming from the PC port, then this tag port of the second switch will attach VLAN ID 4 or the tag 4 with the frame. And once this tagged frame will arrive at the first switch, then this first switch would know that this is destined for VLAN 4, since the tag of VLAN 4 is attached to this frame. So this VLAN tagging is part of IEEE 802.1q standard. Now if the traffic from both of these switches wants to go out from these switches or from the VLAN, then we can send this traffic by declaring another port on the first switch as trunk port, and we will associate VLAN 4, VLAN 5 and VLAN 6 with this trunk port, and we'll do it on both sides, that is on the firewall or router and also on this first switch. So firewall and router will expect the traffic from these three VLANs based upon the VLAN ID or the VLAN tag associated with the VLAN frame which it is receiving from the switch. So once the switch will send traffic or the frame to the router, then it will attach the VLAN ID or the VLAN tag of this frame, and then the router would know that to which VLAN it belongs. Now there's another important concept of native VLAN. Now this native VLAN is defined on the trunk port on both sides, that is between both trunk ports on both switches, or between the trunk ports of firewall or the router and the switch. Now this native VLAN does not have any VLAN ID, and this native VLAN is only is defined per trunk. So, and this native VLAN ID should be same on both sides of the trunk link, that is on the router and on the switch, or between two switches. Now once a switch would send a traffic to the other end of the trunk port, so it will strip off the tag of native VLAN, and once the router will receive the traffic from or the frame from the switch without a tag, then it would know that it belongs to native VLAN, because only the frame without tag are for the native VLAN. So it will once it will receive the frame without a tag, then it will think that this belongs to native VLAN. It will send this frame to the native VLAN ports. So why we use this native VLAN? We use it for management purposes. For example, if the trunk goes down, then the tagged frames are unable to reach the switch or to the router, but the untagged frame would still flow. And since this native VLAN does not have any tagged frame, therefore its traffic would reach the device. So by default, the VLAN 1 is the default native VLAN, but this VLAN ID can be changed. Now there is another important concept of routed VLAN interfaces. Now routed VLAN interfaces are the logical interfaces with an IP address. So we will define this logical VLAN interface. So these are VLAN interface and these are logical interface, and these have IPs. So if the switch operates only at layer 2, then we cannot define the routed VLAN interface on this switch, and therefore we can use the firewall or a router or any layer 3 device for this purpose. So we will create a logical VLAN interface with an IP address, and then we will associate this routed VLAN interface with a particular VLAN ID. So it means that now it will serve as a gateway for all the traffic of this VLAN. So we will create a routed VLAN interface for VLAN 4, and we will create a separate routed VLAN interface for VLAN 5. So if the traffic from VLAN 4 wants to go out to VLAN 5 or to any other outside world, then it would first go to the routed VLAN interface since it operates at layer 3, and then it will go out from that routed VLAN interface to another VLAN. So for inter VLAN communication, we use this routed VLAN interface, and we can define this routed VLAN interface on the switch if this is a layer 3 switch, or we can define it on the router or firewall. Now another important concept is private VLANs, and I am explaining this concept at the end of this video, or at the later part of this video, since this encompasses all these concepts I have explained earlier. So this is a hierarchical VLANs, or we can say this is a hierarchical VLAN concept. And in this hierarchical VLANs, we have two hierarchy. First is the primary VLAN, and in this primary VLAN there are multiple secondary or sub VLANs. And in these secondary or sub VLANs, there are two types of VLANs, that is isolated VLANs and community VLANs. Now first of all, I will talk about top VLAN, that is primary VLAN. So this is just like a normal VLAN, and it has a promiscuous port which serves as a gateway for all the sub VLANs. So this promiscuous port can be accessible by all the sub VLAN ports, or all the ports which are in the sub VLANs. Either these ports are in the isolated VLAN, or either these ports are in the community VLANs. And in the secondary or sub VLANs, there are isolated VLAN ports, or the ports which are associated with the isolated VLAN, and there are multiple community VLANs which are just like VLAN 6. Now once we talk about private VLAN as a concept, then we are mostly talking about isolated VLAN feature, because in this isolated VLAN, this is a single isolated VLAN which has multiple ports attached to it or associated with it, but these ports will not communicate even with each other. So these ports will only communicate with the promiscuous port, but these will not communicate with each other or with the ports in the other VLANs, that is the community VLANs. So we will define a single isolated VLAN and we will define multiple community VLANs. Now the ports in the community VLANs can operate or can communicate within the community. That is, all the ports belongs to a single community VLAN can communicate with each other, but these ports cannot communicate outside the community. And all the ports in the isolated VLAN cannot even communicate between each other. These will only communicate with the promiscuous port. And all the ports in the isolated VLAN and all the ports in the community VLANs will communicate with the promiscuous port in the primary VLAN. Now at the end I will discuss this VLAN attack that is called VLAN hopping attack. And VLAN hopping means the traffic from one VLAN will cross its VLAN and will go to another VLAN in an unauthorized manner. So this VLAN hopping is performed in two ways, and first way is called switch spoofing and second method is double tagging. So in switch spoofing, this is caused by the default configuration of the switch, and in this default configuration we have enabled the auto trunk negotiation feature of the switch. So what does this auto trunk negotiation feature does is that any device can spoof itself as another switch, and once the native switch would think that there is a device or a switch on the other side of a port, then it will configure or it will let the other device to configure its own port as trunk port. So what attacker does that, he uses a laptop and he configures his laptop as a switch, or he spoofs his laptop as a switch, and then he tries to connect to another or the target switch, and the target switch would think that there's not a laptop but it is a switch trying to connect to it, so it will configure its port to which that attacker laptop is trying to connect as trunk port. So this gives the ability to the attacker to communicate with a trunk port, and therefore to communicate with multiple VLANs, since multiple VLANs are configured on trunk port. Now second method is of double tagging. That is, an attacker would attach two VLAN tags with a frame, and first VLAN tag would be of native VLAN, and since the attacker knows that this native VLAN is mostly VLAN with ID 1, therefore it will attach the tag of VLAN ID 1 with a frame, and he will then attach another VLAN tag behind this first tag of target VLAN. So he will send a frame which will have two tags. First tag would be of native VLAN and second tag would be of target VLAN, and it will send this frame to the tagged port or to the trunk port. Now the switch would forward, before forwarding this frame on its tagged port, it will first strip off the native VLAN tag, since the native VLAN do not require a tag. So this switch won't see the second tag behind this native VLAN tag. It will just think that this frame is of native VLAN tag and there is only one tag. It will not see the other tag. So it will just strip off the native VLAN tag, and then it will send this frame to on the other side of the tagged link. And on the other side of the tagged link, the second switch would once receive the frame, it would only see the second tag that is of target VLAN. Since the first tag was stripped off by the first switch, so it will only see the second tag of the target VLAN, and it would think that this frame belongs to this target VLAN, and it will strip off the second VLAN tag, and it will forward the traffic to the second VLAN. Now there is an issue for the attacker with this methodology because it is only one-way trip. Since there are two tags involved and attacker is sitting in VLAN, native VLAN with VLAN ID 1, and the traffic has reached the second VLAN, and the second VLAN has no method of returning this frame to attacker since there are two tags involved. Therefore it is only one way round, one way trip. So attacker can use this method to carry out denial of service attack only. So what we can do to prevent this? First of all, for first method, that is laptop spoofing as a switch, we can disable the auto trunk negotiation feature of the switch. So switch won't allow any other switch to automatically configure its local port as trunk port. And for the second attack, that is double tagging attack, we can change the native VLAN ID from VLAN 1 to any other VLAN ID of our choosing, so that attacker won't use the native features or native VLAN ID for performing or for formulating the first tag. And we can also enforce the native VLAN tag on the trunk port. It means that now the both sides or both ports on both sides of the trunk link will now expect that the traffic even destined for the native VLAN would have a tag. So they will only forward the traffic to the native VLAN if the tag is there, and they won't remove the native VLAN tag before sending it out. So even the attacker is using the native VLAN tag and then another tag behind this native VLAN tag, then the other tag won't be able he won't be able to use the other VLAN tag, since the native VLAN tag won't be removed by the switch, the first switch. This was all from my side. Thank you, and please comment on this video and remain connected to my channel. Thank you.